Good morning, everybody, and welcome to today's Arcserve Weekly WebEx. My name is Charlie Smith. Today I'm going to go through a kind of overview of Arcserve UDP, Unified Data Protection, and what it's all about. I'm going to talk about what's kind of going on in the industry and why we believe customers are looking for new data protection technologies in their organization and in their IT infrastructure. So we're going to go set the scene about that. We're going to go through a kind of reference architecture of how we would deploy UDP in your environment. And we're also going to talk about some of the key functionalities in the solution set. We're also going to talk about our appliances. We now ship Arcserve appliances, and also talk about the Arcserve Cloud, and last but not least, the new release of UDP version 6. So without any further delay, I'm going to get underway. Just before we start, though, I just want to mention that if you do want to raise any questions, we do have a questions panel in the GoToWebinar software. So I encourage you, if you do have any questions, please raise them in the GoToWebinar questions panel, and I'll review any questions at the end of the session. Thank you. So I often ask the question when I'm speaking to customers, are you in control, and do you have the right recovery points and recovery time objectives set up for your organization? Because often when I speak to customers, they've been using maybe a data protection product for the last 5 years, and traditional backup recovery products were really designed in the era when backups were run once a day. You know, you kick off an evening backup and your backup would run overnight, and hopefully the backup would complete before your users come into the office the next morning to access the IT systems. That's how it was traditionally done. But what we're seeing now is that with virtualization and IT becoming so fundamental towards the business, gone are the days where, for example, if you lost a critical database or a messaging system or an ERP application or database, that you would, conceivably lose up to 24 hours worth of change data. And that's because you would have to recover the system for last night's backup, depending on what time of the day, the following day, the system failed. And it's not until you actually think about that and the implications of that, you suddenly realize that actually some of my more critical systems need to be protected more. Data can you afford to lose? The recovery time objective is a bit more well understood. It's simply how long does it take you to get those IT systems that have failed back online in a DR situation or a server outage situation. And for most customers, that's quite a reactive process, because you obviously have to detect the failure, which could be a customer phone, one of your users phoning the service desk. It could be your automation and systems management software picking up an alert. Or it could be simply a case of, a system's gone down, the IT guys investigate the problem, determine that it's a major problem, and the system will need to be restored onto either a new piece of hardware or it's a virtual machine that needs to be re-recovered. And depending on the size of that server, it could take several hours to rebuild that system and recover everything back. So that costs organizations a lot of downtime, which equates to loss in revenue in many cases. So recovery time and recovery point objectives is kind of DR terminology to set service level agreements from the IT department to the business on what is the correct level of service that should be put in place from a data protection perspective, which is how frequently do we need to protect the data, and what is the SLA on the recovery, And it's not untypical now where we speak to customers and they'll say, well, actually, we have an SLA for our tier 1 servers to be up and running within 1 hour or 4 hours, and we can't afford to lose any more than 30 minutes worth of data on certain systems if they're business critical. So, I think the IT department are getting much more savvy now with the business about setting SLAs. The challenge, however, is that if you're using a legacy backup product, it's very difficult to implement flexible RPO and RTO control when you're using a product that was only designed to ever back up your data once a day. So that's one reason why customers change. And the other challenge, of course, is that not all your infrastructure is state of the art. You've probably gone out and spent a lot of money on virtualization infrastructure, so that's new storage area networks, you know, blade server chassis, high performance spec servers, you know, licensing from VMware or Microsoft Hyper-V or KVM or whatever virtualization platform you're using. And that's great, and a lot of customers will go out and buy a kind of niche virtual backup product, back up the disk, and it works quite good and it's easy to manage. But then you've got all that legacy stuff that you've got to manage as well, all these physical servers, you know, and most customers, when I go and speak to them, they still continue to use their legacy backup product. So some of them are backing up directly to tape, or they're using disk staging where they keep maybe less than 24 hours worth of data on disk before it's spun off to tape. And this becomes a real nightmare to manage because you've got an old solution that's very old and clunky, requires a lot of IT intervention in terms of tape management and nursing the backup technology. You've got a new product that's quite slick and easy to manage, which is more automated. But then you've got the challenges, you've got lack of visibility across your whole environment. You've got two consoles to manage, two sets of reports, you know, two different kind of alert mechanisms, and sometimes it's not untypical. I spoke to a customer a few weeks ago. They had 5 different backup products in place, and that was because the company acquired different businesses and inherited their IT systems and their backup processes along the way. So having multiple solutions is a bit of a nightmare because you've also got multiple vendors to deal with, you know, renewal costs, etc., as well as managing the actual systems, which is very inflexible. The other challenge, of course, is that your data continues to grow at an astronomical rate. And it's not untypical now where you see businesses growing at sometimes 20, 30% per annum, some are 10% per annum. But the thing is that from a physical perspective, data growth is not so much of an issue because you can now buy high density, low cost storage, you know, that can basically replace the same amount of disk space as your old disk systems. So when organizations double in capacity every 2 to 5 years, it's not really an issue from a hardware perspective because technology's moved on and that's quite straightforward. But the problem is how do you manage the data protection in an effective, timely way? If your backup window has been stretched 5 years ago, you know, it's going to be completely pulverized now, because the other thing that I see quite often is when I go and visit customers is that they start to take big risks with their data protection. They say, well, look, we just don't have enough time to back up everything fully every day. So what we do is we just back up certain directory structures on certain servers and we cherry pick the data. So that way, if something goes wrong, we know that all the important data is backed up. But the problem with that approach is that the systems are not protected. And if you ever have a server loss, yes, you can recover a file system structure or a database or an application, but you have to manually rebuild the system to recover that data onto, and that's going to cost severe downtime. So really, that's another driver for new technology, a more intelligent way to protect the data that's growing on a constant basis. So what do we do? Well, we've been in the backup and recovery industry for over 25 years. Arcserve has been around since the early 90s. In the 90s, Arcserve was a leader in the Novell file and print backup market, probably the market leader towards the 90s. It was acquired by a company called CA Technologies in 1996. And over the last 15 plus years, CA developed the product more into open systems, Windows, Unix, Linux environments. And then about 5 years ago, the business unit under CA at the time decided that we needed a radical rethink about how we were taking Arcserve forward as a technology. So we made a collective decision to go off in a different direction to most other backup vendors and start to develop incremental block-based image backup technology called D2D. And D2D really set the foundation for our next generation backup platform, UDP Unified Data Protection. And UDP has really been designed from the ground up to be very optimized for virtual server protection, but it also has a big advantage that it protects physical environments as well. And with UDP, we've put a lot of management in place to help customers reduce risk by being able to set the right level of protection, the right RPO and RTO objectives for different groups of servers, reduce the complexity to have a single solution that can manage everything across your environment, and also improve capability. UDP isn't just a backup technology, it's a fully automated off-site disaster recovery solution as well. And it also provides good integration into cloud storage and other remote destinations as well. So it really is an all-encompassing data protection solution. So when you take this infrastructure we were talking about before, which is difficult to manage because you've got multiple backup products, etc., with UDP in the environment, we can now put nice single solution in place, which is SLA and SLA based, one environment to deal with, a very intuitive web console that's very plans, and you can basically have different plans with different groups of servers in them, and each of these plans will have a different combination of tasks to provide the right level of protection for that group of servers. So you could have, for example, a standard plan or a good policy, which is daily backup to disk. Maybe a standard SLA is once a day backup. For your low, mid-impact servers, tier servers, you know, a daily backup's absolutely fine. It could be offloaded onto tape, or it could be creating a virtual copy of the backup, so if something goes wrong, you can spin up a server quickly. So that's kind of like a good plan. You could also have a sort of a tier 1 plan or a platinum plan or whatever you want to call it, which could be a high frequency backup where you're doing multiple backups throughout the working day to minimize data loss. You can automatically replicate recovery points off-site to protect the data in an automated way. Instead of having to do everything to tape, you know, you can replace tape with a remote site or the cloud to automate that process of getting the data off-site. It could be that you want to create virtual clones from the backups, but not on your local site, but do it at the remote site, the DR. So we can set that up as well. So you can build these plans, and these plans can be completely customized with a set of tasks you need to protect that environment in a good way. And the best level of protection is that with UDP, we can manage asynchronous real-time replication as well. So this is not just replicating the backups, this is actually point-to-point replication of the physical and virtual servers in your organization. So if you've got critical databases that even if you lost 10 minutes worth of data would cause an impact to the business, we can actually replicate databases and full systems and keep them completely mirrored to a DR site that you can automate switch over and spin up DR standby systems if the production servers fail. So that's the best level of protection, which is continuous replication of your physical and virtual machines. And really that's what UDP is all about. It's about providing enterprise class functionality, you know, really strong data deduplication. I'm going to explain how that works. Integrated replication, very strong protection of servers, but also an environment, you know, a solution that can span physical and virtual. It can provide on-premise protection and integration into remote locations in the cloud. But the key thing about all of this is making the management simple and easy to use. The danger with any backup vendor is as you start to make a solution very feature-rich, it can become very complex and sometimes for some vendors become very expensive as well. And the challenge with that is that it kind of loses its appeal. So what we've tried to do at Arcserve is add real strong enterprise class functionality, but keep it intuitive and easy to use and easy to manage, which is really a feat of great engineering, I suppose. Now, what I'm going to do now is talk through a kind of solution architecture, how we would deploy Arcserve UDP in the real world. So if we take your data center or your primary site, the chances are that you're going to have a predominantly virtual infrastructure for most customers now, but you'll probably still have physical servers that you need to back up and protect as well. Now, we deploy a server into that environment called an RPS, which stands for Recovery Point Server. The RPS server can be delivered in two ways. It can be deployed under a software license where you use your own Windows server and storage, and we install our software onto it and turn it into a global DGP appliance. Or you can actually buy an all-in-one appliance from Arcserve, which has the compute, the storage, and our software all integrated and bundled together to provide an out-of-the-box, easy-to-deploy solution that will protect your environment very easily and quickly. So the technology can be delivered in different ways, but essentially from a technical, functional perspective, it's exactly the same. So this recovery point server provides global dedupe. And our dedupe technology is very advanced in the fact that we do what we call source-side global dedupe. And what that means is that when we're backing up lots of servers, so for example, you could have a VMware environment and you may have a plan, a data protection policy, and you're going to back up 100 VMs. Now, when you snapshot those 100 VMs, the backup solution will integrate with the VMware APIs, for example. It will use VMware's change block tracking to calculate the block level incremental changes since a previous snapshot had been taken. So for example, you could have 100 gigabytes of data to back up. Now, most backup solutions would transmit the full size of those change block backups across the network to their media server. And the media server, even if it does support dedupe, will basically commit unique blocks to disk, and it will discard the vast majority of the backup because it's duplicated data. Now, what we do is we take the same snapshots using the VMware APIs and the change block tracking, but what we do is before we transmit any backup data, we communicate with the RPS server and actually calculate what unique blocks we need from those snapshots. So instead of sending 100 gigabytes across the network, I may send 2 gigabytes across the network because we're intelligent enough to work out what's unique at source. But then at the back end, we're doing inline target-based global dedupe. So we're doing the dedupe as we're reading the data in. So we're very efficient at compressing and deduplicating the backups. We're using global dedupe as well. So if I back up 100 servers and they're all running Windows 2012, I'll only back up the OS once and reference the same blocks to all the other 99 servers being backed up. So we're globally deduping, and essentially what we're doing is we're only pulling the unique blocks from each system because all the common blocks are globally deduped. And what that means is two things. The backups run really quickly compared to most other backup solutions because we're only transmitting the unique blocks from source, and the actual backup footprint in terms of the capacity used at the back end is very, very significantly reduced. And it's not uncommon now. We have customers regularly getting 94, 95% data reduction on their backup data. So, you know, we had one customer backing up over 500 terabytes of data, and on disk they actually hold 27 terabytes of backup storage. So that's a significant reduction in terms of what they're protecting at the front end versus what's actually compressed and held on disk. So the RPS server has an important role to back up and process the data, but also reduce, by using very advanced data deduplication technology, reduce the backup footprint. Now, we also have the ability to migrate off to tape. It's amazing how many customers still use tape. What we're seeing, though, is a big shift in strategy around tape, that tape is no longer used as a primary backup target because it's too restrictive in terms of the number of drives and the number of streams, and it can become a bottleneck for backup times and performance. But where tape really becomes very useful now is if you need to keep backup archives for very long periods of time. So we deal, for example, a lot with the public sector, NHS, finance, commercial customers in finance, where they need to keep certain backup records for 10 years, 20 years, sometimes for a lifetime of the data. So by being able to use an intelligent combination of disk-based backups and maybe do a monthly archive off to tape just for compliance reasons makes a lot of sense. However, there are two kinds of customers that we see. One, customers that recognize tape is still a very effective and affordable medium to store data for long periods of time. But we also get customers that just want to get rid of tape completely. And that's where using, for example, off-site replication, where we can replicate backups to a DR site and almost have a second copy on disk, which is automatically replicated off-site. Removes the need to do things like daily copy to tape, because you've already got a second copy off-site, and there's no manual involvement of tape management and IT people running around ejecting media, running reports, bringing media back on site, scratching and erasing tapes, re-barcoding labels. Those kind of days are what a lot of IT departments want to get rid of, because it's just all-encompassing and very time-consuming. As you can start to see in this diagram now, we're really building it out. We can bring in remote office branch data in an intelligent way and replicate that to your head office, or it could be that you want to take your remote branch office directly to the DR site. We can route the traffic, the data traffic, however you need to do it. We've also got integration into the cloud as well. So we support things like Microsoft Cloud, Amazon Cloud. We've also got the Arcserve Cloud service. I'll talk a bit more about that in the coming slides, to provide off-site disaster recovery. The cloud, I suppose, is quite an exciting advancement in data protection, because a lot of organizations may not have a DR site, or even if they do have a second site, the cost of maintaining hardware, constantly having to refresh kit that's hardly ever used because it's purely there for DR purposes, is seen by the business as a very expensive way to provide disaster recovery. And a lot of companies now are looking at more intelligent, efficient ways to do that. So by replicating to a cloud, you're not having to invest in that compute power to support your DR strategy. It's all done automatically, and you pay a subscription to provide that service. So that's becoming really popular now. Now, once the data gets to the DR location, we really have very clever technology. We have virtual provisioning called virtual standby, which can convert your backup recovery points on disk into bootable VMs. And it doesn't matter if your production server is physical or virtual or a combination of the two. We can basically spin up all your backups as virtual clones within a few minutes if a production server fails. And that clone will come up onto the network as good as the last backup taken, or any previous recovery point, because you can actually specify in the policy how many bootable recovery points you want to maintain in a cycle against those clones. So virtual standby is all about fast recovery time objectives. We also have a new virtual standby capability called Instant VM, which allows you to be able to spin up the VMs dynamically straight from the backup set without having to create the clone ahead of time in a virtual data store. The other thing about virtual standby and Instant VM is it works across hypervisor. And what that allows you to do is, if, for example, you could be backing up VMware in production or physical servers, we can spin up, for example, your production servers into a Hyper-V environment. So we don't need to have the same hypervisor deployed at multiple sites for DR purposes. And when we talk a bit more about the Arcserve Cloud, we have a whole Hyper-V layer in our cloud that we can spin up your production backups in the cloud and provide disaster recovery as a service using Hyper-V. So that's kind of giving you a kind of idea of how we deploy Arcserve. It can be as simple or as fairly complex as you need it to be to cover all the site data requirements. Now, the key thing about all of this is this can be centrally managed from a single web-based console. So you've got visibility of all tasks across all sites running in your environment. We've also got the real-time replication and HA technology as well to provide a near zero RPO experience around critical data sets. And we'll talk a bit more about that over the coming slides. So this is just a screenshot from one of our customers in the south of England. They're predominantly virtualized and they're predominantly Windows. And in this example here, they were backing up just over 250 terabytes of production data. And in their data store, after compression and dedupe, they were actually holding just under 15 terabytes of backup data. Now, this person who will remain nameless, I should say, wrote an article on Spiceworks, and that's publicly available on their experience of deploying Arcserve in their environment. The person actually put graphs up showing you how the dedupe kind of improved over time to give them very impressive compression rates. They actually use a second RPS data store in the Microsoft Cloud, and they're using the Microsoft Cloud as their DR platform for off-site replication. So that's interesting. Just also to tell you that we've launched UDP version 6 in February this year, and UDP version 6 really kind of took us forward from version 5. Version 5 was a great release for us. We launched UDP version 5 in May 2014, and within the first 12-15 months, we actually had 10,000 customers running UDP. A phenomenal uptake on our technology. But we also recognize that, like everything else, you need to improve and refine the product as you go forward. So UDP version 6 was really about unifying the product, making it much more intuitive, especially around the installation, making it much easier and slicker to use. We've done a huge amount of development around Linux to bring Linux up to the same functional parity as Windows, and also provide some really exciting enterprise class features into the product around snapshotting using hardware integration, and other enhancements around role-based management and command line integration. So with version 6 now, we believe it really helps us leapfrog our competitors in many ways. It's really just making the product better than ever, because UDP version 5 was great, but version 6 is even better. We're just kind of bringing everything together, refining the product, and we've had some great uptake now. I think we've got something like over 3,000 customers have moved to UDP version 6 since February this year. So it's kind of going really well for us at the moment. So version 6 is all about improving data protection even more. We've now got a lot of management enhancements around role-based management, command line PowerShell now to script things into the backup server area. We've got rebootless agents now, so when we're deploying the technology, we don't have to schedule downtime on the servers to bring in agents. And we've brought in a lot of new exciting recovery capabilities around Instant VM as well. This is just a screenshot of our new Exchange granular restore capability. With the new GRT Mailbox tool, what we're able to do now is recover anything in a user's mailbox. So with version 5, we had the ability to recover emails. With version 6 now, we can recover calendar items, contacts, emails, public folder items. And the great thing about this tool is we don't have to do any additional processing on the backup either. So when we take an Exchange backup now, we just simply snapshot the databases using the VSS writers for Exchange, and we don't need to run a GRT scan or a brick level backup. We just simply mount the Exchange backup into the GRT tool, and it will index the Exchange database from the backup volume as it loads it up. And then you can go, it's like going into Outlook, you can basically select anything in the user's folder. And we'll actually show you this in the demo today. Now, as we've mentioned, there is different ways you can license UDP. One option is to use a software-only license where you use your own hardware or you buy new hardware from your reseller or partner. And there are different editions of UDP. We have Advanced Edition, which is all the standard UDP functionality, including the ability to replicate recovery points between sites, do our application-aware backups using virtual standby and instant VM recovery, is all part of the advanced license. We also have a premium license. The premium license provides everything that's in advanced, but it also gives you access to some more of the enterprise class features like hardware snapshot integration, role-based management, full tape support. So if you've got a large tape library unit with multiple drives and a robot controller arm, it can manage all of that with the premium license. And then the highest edition we have is Premium Plus, which is everything that's in Premium plus the ability to do the real-time replication and high availability of physical and virtual machines. So that's the different editions that we have. We also have different ways to measure the license. So we have per socket, which is really good if you're predominantly virtual. We add up the physical CPU socket count across all your virtual hosts and any standalone physical server that you have in your environment as well. and we just give you an all-you-can-eat license based on the number of sockets across your physical servers. We also have a per terabyte license, which is how much data you're protecting. So if you were to do one full backup of all your physical and virtual servers, how big would that backup be to the nearest terabyte before we compress and dedupe the data? So it's a front-end data size that we're protecting, and we round it up to the nearest terabyte. We also have a per server license, which is available for the advanced edition only, and a workstation license. If you want to back up Windows 7 to up to Windows 10 workstations and desktops, we can do that with the workstation UDP license. So that's kind of how we license the software. We've also launched in the last 12 months appliances. We started to recognize that the market was rapidly changing, and the appliances were becoming very popular with customers. Customers really like the idea that instead of having to go out and buy their own hardware, own storage, buy all the software licenses, then they have to install it all and manually set it all up, is that they can actually buy an all-in-one unit, which is basically a server with the storage and the Arcserve software all bundled together. And they literally just have to rack mount the server, power it on, register an IP address, put it onto the domain, and then you're ready to go. You can discover all your servers that you want to protect, create your policies, and start backing up and deduplicating all the data. We have 6 appliances in our range, the 7100 all the way through to the 7600. The smallest appliance will protect up to 8 terabytes of data, and the largest appliance protects up to 90 terabytes of data. And then we have 5 models, or 4 models in between that. So we have the 17 terabyte, which is a 7200, 26 terabyte unit, which is a 7300, and then it's 46 and 58 terabytes, which is a 74 and 7500. So depending on how much data you have, an appliance can be quite an attractive proposition. One of the things that's really popular about the appliance is that the license for the backup is built into the cost of the appliance. So when you buy an appliance, there's no additional software licensing required. You can back up as many physical and virtual machines that will fit onto the storage of that appliance. Okay. We've also got the Arcserve Cloud, and this has become really popular now, where a lot of companies are really kind of fed up. Either they don't have their own disaster recovery and they traditionally use tape as a DR element to their backup solution, and they want to get rid of tape, or it could be a customer that's had their own DR site, recognize it's not a very cost-effective way to manage DR because you're having to refresh kit that hardly ever gets used. The cloud becomes really attractive, and the Arcserve Cloud is really nice because it fits seamlessly into UDP, both from a software and an appliance perspective. So the cloud provides kind of 3 main services: off-site data retention, that we can basically almost replace your tape by replicating to the Arcserve Cloud and retain backups in the cloud for longer periods of time. It can provide off-site disaster recovery because it's not just about getting the data into the cloud. We can provision your backup images into a Hyper-V environment and spin them up and present them back to you on a virtual private network that you can access if your production systems fail on site. So we're providing DR as a service from the cloud, but also as in the same sort of areas that we can also provide DR testing. So if you want to spin up new clones just purely to run a yearly or bi-yearly DR test, we can do all that work as well, and that's all built into the cost of the cloud subscription. And this is simply how it looks. If you buy an appliance, we just sell you the cloud equivalent appliance, so for example, if you bought a 7400 appliance in your environment, you would also purchase a 7400C, which is the same size of appliance in our cloud. And your environment is completely separated from any other customers. We don't share back-end data. It's all completely isolated for each customer. And as well as being able to give you a cloud-based virtual appliance to replicate to with the same storage capacity, you also have a Hyper-V layer that we can use virtual standby to provision into as well. Even if you buy a software license, we can also sell you the Arcserve Cloud, but we simply measure it on the amount of dedupe data you're going to be uploading to the cloud. Okay, now our cloud data centers for EMEA and Europe is in the Netherlands, which is obviously inside the EU. We provide a very resilient data infrastructure there. We guarantee a service of 5 nines of availability. The environment is highly staffed. It is monitored 24/7 by 365, and it's a very secure, reliant site in the Netherlands. We also have cloud data centers in other parts of the world, and we're planning to deploy in other geos around the world as well. So what's next? Okay, I'm going to go and give you a demo shortly, but just before we do that, just to say that if you go to arcserve.com, if you're in the UK, go to the UK site specifically. If you're from outside of the UK, if you just go to arcserve.com, it will take you to your language set from your browser settings. And there's loads of information available. There's data sheets, white papers. We have a big case study reference library now of customers who have purchased Arcserve and seen the benefits and have been so happy with the outcome that they've publicly, endorsed us, which is a great thing. There's also access to get a live trial copy of the software. You can download a 30-day live trial, which is a fully functional license. You can deploy it across the environment, test it fully. Every feature is enabled in the live trial license for 30 days. There's also a whole wealth of information. We have a support site with knowledge bases. We also have a lot of information in basically YouTube, where you can look at videos about how to set up the cloud, how to set up appliances, how to do instant virtual recovery. All these different areas of the product are all videoized in a video tutorial, so it's really nice and easy to get access to information as well. So what I'm going to do now is, I'm just conscious of the time, I'm going to basically go into a live demo. So I'm just going to end this slideshow for a second. And I'm going to go into the Arcserve UDP console. Now, the console is web-based. It uses all the latest Web 2.0 and HTML5. And when you first log in, it takes you to what we call the dashboard view. The dashboard gives you a kind of 7-day rolling view of what's going on in your environment. So you can see the backup status over the last 7 days, your dedupe ratios in terms of how much you're backing up and how much is actually restored on disk. My dashboard is just in the process of refreshing at the moment, and there we go. And it gives you a nice rolling view of how efficient the dedupes are. Now, my lab is not a representation of a real-world environment. It's just a few virtual servers and some physical machines that I'm backing up. But in a production environment where you're backing up enterprise environments, you get very detailed graphs showing you the changes. This is also showing me at the bottom left here how much data is recoverable in my environment. So if I had to do a full system recovery of everything, I would have about 800 gigabytes of data to restore in my lab, which isn't a huge amount. But in a production environment, that could be 500 terabytes. And then it's actually showing you how much is stored on disk. So the dashboard kind of gives you a nice view, a simple window as to what's going on in your environment. And I can see that everything there is looking quite good. When I go into the resources tab, the resources is where you do most of the day-to-day management from. So if I want to add nodes and I want to back up, I can connect into my VMware environment to discover VMs that I want to protect. So you can connect into a virtual host or vCenter. I've got a virtual host in my lab. But in a production environment, you would normally connect into your vCenter server, see your vCenter organization, all your sites, and all your storage pools. And you can basically go in and add VMs that you want to back up. We've also got a discovery for Hyper-V, and we fully support Hyper-V clusters as well, where we can go in and discover the VMs that are running in your Hyper-V environment and to import them into the database as well, or so we can manage agentless backup in Hyper-V environments as well. If I want to add in physical servers, there's different ways to do it, but the most common way is to look up your AD and then select the servers that you want to manage and then add them into the database as well. Now, once you add the servers into the database, there's different ways we manage it. If for physical servers, we push out agents, and these green icons here show me that these servers have got agents installed. And you can see here that When I hover over it, it tells me the version and the build number of the agent as well. Now, to push out agents from the console is very simple, or update existing agents. If you bring out a new update, you just basically select Install Upgrade Agent and then say OK, and it will push out the latest update or a new agent if it's a new server, and you'll see it copying the data over the network, installing, and you get a summary of what progress has been made with the installation. So it's all pushed out from a console. It normally takes just over 5 minutes to push out an agent onto a group of machines. It's very quick. And once the agents are installed, we don't require any reboots. It's all completely rebootless, so we can push them out. For virtual machines, we do what we call a pre-flight check. So we check the environment's ready for backup. So we're checking that change block tracking is enabled, so we can capture the change incremental blocks. For VMware environments, we check things like VMware tools are installed, because we quiesce the server using the VMware tools. So if you're running things like SQL Exchange, we're creating the database consistent backups using the VSS writers inside the VM. And we're also checking the disk, the power, the data is consistent, etc. as well. So once you've done your agentless discovery and pushed out your agents, we then set up what we call our recovery point servers. The RPS servers are basically our backup engines. This is where we're backing up to on disk. I have two servers here. I have one called Manager, which is my on-site backup server, and I also have one in the Arcserve Cloud, which is providing my cloud DR offsite replicated copy. Now, when you basically add a recovery point server, you add what we call a data store. A data store is a storage pool, and if I modify this one, you'll see that it's a set of directory structures that we create on disk. We have a data, an index, and a hash path. The hash destination is a dedupe database. We tend to recommend as a best practice to use SSD storage for the hash database, which gives you the best performance, because we have to read the data very quickly from the hash database, especially when we're doing restores to piece all the data together. So we do recommend SSDs, but you can also run the hash destination in RAM mode, where you can allocate a chunk of RAM to the process. So if you've got a lot of RAM on a server, you could basically just put 32 gig of RAM allocated to the hash destination and take that tick off and run the hash on a standard NTFS volume. You can also enable encryption. We use 256-bit AES encryption. You can also control how many concurrent nodes can back up to a data store at any one time. So the default is 4, but that's based on the assumption using a gigabit network. If you've got things like 10 gigabit Ethernet, you may be able to increase that by maybe to 20 streams or something quite significant, because you've got the bandwidth to pull in all these streams across the network. We can also set the block size. The default is 16K. The smallest block size is 4K. With small block sizes, you get very impressive dedupe ratios, but then there's a slight trade-off that the restore time or the recovery time is slightly longer. The larger the block size, it gives you very fast recovery time, but the dedupe is slightly less efficient. So 16K is kind of middle of the road. It gives you the best overall performance, balancing data usage versus recovery performance. So once you create that, that initializes, and then if you go into the data store, it shows you what servers are backed up to it and how many recovery points you have available. You can see here, you get a history of when the servers were backed up, and you can see here that I'm doing incremental forever backups across this environment. So once you've got that up, I've also got a cloud RPS server and a cloud data store, which is set up in a similar way. And then the last thing we need to do is create our plans. Now, when we create a policy or a plan, it isn't just a backup policy. It's a workflow, a set of end-to-end tasks. So here in this VMware plan, I've got basically 4 tasks created. One is to do the agentless backup using the VMware APIs. And each task has got a set of fields. So this is what nodes I want to back up, so I can add more nodes if I want. Add them all in there, for example. And then I can say, where do I want to back up to? So it's backing up to my recovery point server and my storage pool production. And then you've got your backup schedules. Now with UDP, there's 4 levels of scheduling. You've got daily, which is the default. You can also add weekly and monthly schedules, each with variable retention policy. Unlike a traditional backup product, when we do weekly and monthly, we can just still select incremental backups, but it will retain those incremental recovery points. For example, for 5 weekly recovery points will be held in the database when it does its Friday backup. And again, for monthly, I'm holding 12 end of month recovery points, so I can actually scale back a year and recover older file versions, etc., going back 12 months with this policy. You can also add in what we call high frequency backup schedules. So if you had a group of servers that you required higher levels of protection, in addition to your daily, weekly, monthly schedules, you may also add in a custom schedule where I can say, between 8 o'clock in the morning and maybe 8 o'clock at night, I'm going to do a snapshot every hour, to minimize data loss. And it's only going to do that Monday to Friday during business hours. Outside of that, it will revert to the daily, weekly, and monthly schedule. You can actually go down to every 15 minutes. The product is designed to do high frequency backups. But you need to set the right level that suits your business. There is a trade-off. Obviously, the more recovery points you take, the more storage you will consume on disk. But having said that, we use global dedupe, and it is still very, very efficient. So you can basically set variable recovery points, and then you have advanced topics like if you want to use hardware snapshot or software snapshot from the hypervisor, if you want to truncate the application logs for things like SQL Exchange, if you enable alerting to get real-time alerts if any job is incomplete or failed or stopped. You've also got placeholders here to run scripts. And then you've got other tasks, and again, you don't have to add all these tasks in. It really depends on what you're trying to achieve. So if you do want to use tape, you can add a copy to tape task, and then basically maybe migrate my monthly backups off to my tape library and manage that. We've also got the ability to do replication, so I can replicate to the cloud, and I can do things like bandwidth throttling and schedule replication at different times if I want as well. You've also got tasks to do virtual provisioning. So in my policy, I'm backing up VMware, and I'm creating the virtual clones in a Hyper-V environment. So I'm connecting to my DR Hyper-V server, and I can create the clones in there. You can give the clones a prefix, so you can identify which machines are your production servers, which ones are your DR. The prefix could be anything you want it to be. So if you were backing up servers and leads, and you put them into the cloud, you could make the prefix leads _ followed by the machine name, and that way, if you needed to do a DR and you have multiple sites to manage, you can sort. And there's been a failure in Manchester, and you know that which nodes are the DR servers for Manchester, because I'll have Manchester in front of the server names. So it's all about ease of management. How many bootable snapshots you want to keep it against the clone? You can have up to 24 in Hyper-V and up to 29 in VMware. How much CPU and memory do you want to put on the guest? Where do you want to create the VHDX files for Hyper-V? In VMware, it gives you a list of all the data stores that you can store it in. And then basically assign in the NIC card on the guest to the host network adapter. So if you've got multiple host network adapters, you can select the correct one. So when the VM powers on, it's on the right network to be accessed by your users. So once all these tasks are being added, the policy gets deployed, and then backups will just start to back up. So I'm just going to kick off an ad hoc backup here just to show you what it looks like. And what you'll notice is that when we start to run tasks in UDP, you get spinning icons appear next to the machines. And what that is, it's just indicating to you that there are tasks running against the node. Now, when you're kicking off most of your backups, most customers at this point will go into their jobs tab, and the jobs is where you monitor all the tasks being run. Because in a production environment, you could have hundreds of tasks running. And what you can do is you group the task by the name of the policy, and that way everything's nested and makes it less cluttered in the console. And then you can go in. Now, if I click on details here, it shows me what the actual job's doing at this moment in time. So at the moment, the backup hasn't actually really started because we're not moving any data, but it will tell me what it's doing. So at the moment, we're sending commands into VMware to take the snapshot of this virtual machine. It's a Windows 2012 R2 server. And in a second, it will tell me that it's taken a snapshot. Once the snapshot's been created, we create a dynamic mount point to the data store for VMware, access the snapshot, and we start to dedupe and compress it as we're backing up. So the whole process normally takes about a minute for it all to kick in. And you can see now it's taken the snapshot. If I go to my vSphere client here, you can see the snapshot being created under VMware. So we're using all the APIs. We do the same thing in Hyper-V, and we're using the APIs from the hypervisor. So that's a snapshot created, and shortly it will tell me it's collecting the backup data, and then the backup will start. You know, now what you will see is when the backup starts to run is that we're compressing the data, we're deduping the data, and we'll give you an overall data reduction percentage. And it's not untypical in production environments that you'll see 95, 97, 98% data reduction, because we're deduping against the data that's already backed up, and that's globally referenced across all the servers being protected as well. So that's why we get very high data reduction rates, because the dedupe's very advanced. Now this is a tiny snapshot, it's only 23 megabytes as reported by VMware. So the backup will be almost finished before it starts because it's that small. But then what you'll see is all the other tasks will kick in. You'll see the replication task kick in, the virtual standby task to update the clone because it's got a new recovery point that's coming, and they all get executed as per that plan that we created. So you can see now the replication is just about to start, and it's going to replicate that recovery point off site, and then all the other tasks associated with that plan will kick in. Now what I'm going to do is, whilst that backup and replication etc. is completing, I'm just going to show you some of the restore options that we have in UDP. So I've just right-clicked the server here, selected restore, and this kind of gives me the granular recovery options that I can do on a physical or a virtual machine. So if I want to recover files and folders, I just select browse recovery points. I select the day I'm interested in. It shows me what snapshots have been taken in that 24-hour period. On this particular day, only one snapshot was taken. And then you can drill in to things like the NTFS volumes. And you can see that it's saying mounting the volume. So we mount the volume in the background, and you browse the backup data directly. So I'm going to recover, for example, this utilities folder and all the files and folders underneath that. And then you've got all the usual options if you want to restore to the original, restore to an alternative. If there's files already exist on that original location, do you want to overwrite them, rename them, skip them, etc. You've also got things like Active Directory integration as well. So if this is a domain controller, we can recover AD objects back in to your server. So here I'm going to drill into my AD, and I can recover users, administrator, you know. This is the admin user. I might be able to just use attributes for his exchange. So you can go right down to attribute. You can recover Active Directory groups. You can recover computers and all their attributes as well. So it's anything pretty much in your AD can be recovered. And what we do is when we recover an object or an attribute, we recover it back to AD, but we don't enable it. So you just need to go into AD and enable the object that you've just restored, and then it's live. We can do VM level restores to recover a complete VM if you want to do a kind of traditional recovery of a VM. We've also got email item recovery. This is a tool I was talking to you about before in the presentation. You can recover anything in a user's mailbox, you know, calendar, contacts, journal, tasks, notes, you know, emails. And you've got two options. You can recover back to the user's mailbox if the user's still there, or you can export it to a PST folder. And it will basically put the files in there, and then, you know, so it's really easy to use. You can recover public folder items and everything in there. So we've got lots of different granular restore options. You've also got things like virtual standby as well. So if a server fails, I can right-click the server, say standby VM, select a bootable recovery point. That's one we just created, and then basically boot it up. And then, as I was saying before, my clones are held in Hyper-V. That's the clone there, and you'll see in a second it will get booted up because we powered it on from the UDP console. And if I click on there now, you'll see that the 2012 server that was actually a VMware image is now being powered up into Hyper-V, so it works across hypervisors. We've actually had a lot of customers recently using Hyper-V for disaster recovery because it saves them a fortune on VMware licenses. Many of our customers have got like Microsoft data center agreements where they can essentially roll out Hyper-V server licenses for no additional cost. So it's just the cost of the hardware and the software of UDP. and then they've got the whole environment that they can automate and use Hyper-V for disaster recovery. But it can be VMware to VMware, or Hyper-V to Hyper-V, or physical to virtual in any combination as well. In addition to that, virtual standby, which I've just showed you there, and that's a machine booting up, we've also got an instant VM as well. So virtual standby essentially creates a clone ahead of time, and it keeps it in sync with your backups. With instant VM, you're booting directly from the backup. So if I say create an instant VM, it walks me through a wizard. So it selects what recovery point I want to do. And then you put in my encryption password. I'm just going to put it in. And then essentially it asks me if I want to boot up into VMware or Hyper-V. I'm using Hyper-V just for today. And then it's telling me that I need to have a UDP agent installed on the Hyper-V server, which I already have. And then I just put in my credentials to connect to the Hyper-V host. And it's exactly the same concept of VMware. You connect into vCenter or the ESXi host. You then have to create a recovery folder. So I've got a mount point. And what we do is an NFS boot from the RPS server. So you're booting up directly from the backup storage, adding in the network adapter, and you can change the settings if you wish, and then select. So I'm going to boot later. And what this will do now is it will actually provision. So it will connect into the hypervisor, it will create the instant VM clone, and it's registered that in there now. You can see it's underneath under the checkpoints, it says Arcserve Instant VM Snapshot. And in the background, it's still setting it up. It's linking it back to that mount point that we talked about, but it's actually connecting into the production data store on my manager server, and it's ready. So that server is now ready to boot on. All I have to do is select power on, and then that guy will come up straight from the backup storage. So instant VM is all about getting that system up and running as quickly as possible. And that is a significantly faster way to do it than having to restore. You know, you can have a server that's like 400 or 500 gigabytes in size, and it would take you an hour to restore all the files back to your virtual environment. With instant VM, you can boot it directly from the backup. And if you're using things like VMware, you can just vMotion it once it's up and running into a permanent data store. So it's really easy, very slick and easy to use. We've also got real-time replication as well. We can replicate servers asynchronously. So this is replicating a Windows 2012 server directly to VMware. What I'm going to do here is kick a DR test off. A DR test is exactly the same as doing an automated live system switchover, but it brings up the DR system into a test subnet, not the production network. And it will test all the application services when it powers on the server to make sure everything is working as it should be on that system. So I've kicked off a DR test with my real-time replication now. It's gone into DR test mode. And on the virtual host, we've just added this server into the inventory, which is a DR test clone. And what we actually do on the virtual host itself, we create a test subnet, which is all automated. And you can see there I have a subnet called Arcserve RHA internal for assured recovery. What we're doing is we take a snapshot of the system, we configure the snapshot to power onto that test subnet, and now that machine is getting powered on. And then in a couple of minutes that server will be up and running, but it won't impact the production server because it's been tested in a test subnet, which is basically not a public network connection. And you can test groups of servers as well, it's not individual servers, and test applications. And what you get once the testing is complete is DR test reports. So if I go into statistics here and records, I can go in and see, for example, a DR test report, and it shows me the status of all the services. So you can come into the office on a Monday morning, kick off all your DR tests over the weekend, all tests offline, it checks all the services are running, and then it shuts the systems down at the end of the test. And you know then that the DR environment's in a good place, ready to go if you ever need it in a DR environment. So we've got that, all that automated DR as well. I'm going to quickly show you some of the reports before we finish today, just to show you what it kind of looks like. So I prefer bar charts to pie charts. I can look at maybe the last 30 days, and if I click on a day, it shows me, you know, the backup status of all those servers. If I want, you know, like for example, on the 18th of May there, I can see I've got a red piece, so I had some failures. So if I want to see what those failures were, I can click on the server and it will tell me. The reason why this backup failed is because the ESXi host was in maintenance mode and I couldn't access it to do an agent backup using the APIs from VMware. So it gives you nice, meaningful, logical messages why a backup's failed on a particular day. We can also see how much data we're protecting across your environment as well. And it gives me a breakdown of all the servers and how much storage I'm backing up at the front end. We can also do backup trending. Now, in my environment, the trending doesn't look very impressive because I'm just backing up a couple of VMs for demos. In a production environment, you get very detailed graphs showing your typical daily backup sizes, and you can also do forecasting as well. So if I want to see what I think, how much storage how much data I'll be backing up in 3 months' time, it will show me a trend. Now, obviously, because my data is quite limited to begin with, the graph doesn't look that impressive, but in a production environment, it looks really nice, and you get very accurate forecasting. Now, all these reports can be scheduled on a daily basis. You can filter the reports by the name of plans. You just want to see backup failures and send them to different groups of recipients, and you can send them in PDF format or embedded HTML, etc. We've got real-time alerting as well. So that's me kind of done. Really today was just to give you a quick run through what it looks like and some of the key functions in UDP. So what I'm going to do now is I'm just going to open it up for questions. In your webinar, GoToWebinar panel, as I mentioned at the start of the session, there is a questions panel. There are quite a few questions raised already. So what I'm going to do is I'm going to end the audio now. I want to thank you for your time, and I'm going to spend 10 minutes answering these questions before I end the session today. So if you want to raise a question, I will be online for the next 10-15 minutes answering these questions in the question and answer panel. But I'm going to end the audio now. Thank you very much for your time, and have a great weekend. Thank you.